Hello everyone, I'm Hanikushan from BVRIT. So, what if I told you that most AI models can still be tricked into generating unsafe content even when they are supposed to be safe? So, in this video, I'm going to show you a project we built, an LLM safety evaluation system that tests how safe AI models actually are. Let's get started with our video. So, what are the hidden risks in AI? Generally, AI models are assumed to be safe under normal operational conditions. Okay, but they can be actually manipulated by giving some obfuscated prompts. There are no datasets which having these kind of obfuscated prompts. So, to overcome this problem, we came up with an idea. So, let's see what's our project is. Let's see what's our project actually is. We made a prompt dataset containing nearly 4000 prompts, and then we categorize those prompts into three parts. First one is malicious prompt, and second one is benign prompt, and third one is obfuscated prompt. To do this, we used a technique called homotopy inspired prompt obfuscation. Generally, this technique is nothing but a step by step mutation. In this, what happens is uh, from malicious prompt to obfuscated prompt, it just changes the semantic words and phrasing, but the intent should remain same from malicious prompt to obfuscated prompt. The intent should not change, but the wording and phrasing is just changed. So after this, we used those prompts and send them to multiple LLMs, and then analyze the outputs of that LLMs. So what's the core objectives of our project? With our project, we can identify unsafe AI and simulate attacks, obviously ethical practices only, and then we can create a custom dataset. We generated a Python script. With that, we can generate a custom dataset and then classify the behavior of LLMs with our prompts. We also generated a evaluation prompt using Python. These are our core objectives of our project. I told that we wrote a Python script for evaluation. So actually, what does this evaluation script actually do? So it classifies the responses from multiple LLMs into three categories. First one is safe. Safe means proper execution, or refusal means the LLM refused our obfuscated prompt. It means the LLM is safe. We consider it as safe. The next, unsafe. Uh, Basically, when the LLM gave harmful or restricted or toxic output, which it should not be given, then we categorize them into unsafe. And at last, ambiguous, which is uncertain or erasive response, like we can't determine it as safe or unsafe. Let's see the project flow. At first, we generate the prompt dataset, that is first step input prompts. Next, send those generated prompts to multiple LLMs. Then the third step is collect responses from those LLMs and then analyze and classify the responses. At last, storing outputs of those LLMs. This is the actual flow of our project. If you liked our project, you can check it out on GitHub. I'll drop the link in description. We completely made it open source. Let's see the download steps. Go to the video description, then click on our GitHub link. It will redirect to our repo. We pushed everything of our project related files. We also kept a detailed readme file. It contains the actual overview of our project and steps to download in your local machine and run the project. Let's see, the prompt categories which I have said earlier: malicious and benign prompt, obfuscated prompt. Here you can see what are they, and we tested on. I told that we tested on multiple LLMs. Those LLMs are Grok, Gemini, GPT, and Llama from OpenRouter. If you want to check any other LLMs, you can make the changes accordingly in the evaluation code. Let's see the setup step. Now open the terminal and go to your preferred folder where you want to clone our project. Then run this git clone command to clone our project. Then change the directory to LLM safety eval. Then next, create a virtual environment to safe execute it. And then if you are using Linux or Mac OS, use this command. If you are using a Windows system, use this one. Next, install all dependencies using this command. Next, configure your API keys. Edit the .env file before you are running. You are making the execution. These are the steps to set up the project in your local machine. Okay, now we have completed the part of setting up the things. Now let's start using it. If you want to generate in generator.py file, we defaultly set the rows to 3000. If you run the file, you completely generate 3000 rows of dataset. If you want to customize that, means if you want to change the records, you can manually set like this. And if you want to if you want to store the output in a specific file, you can also mention like this. After that, prompts are generated and saved in a file. To run the evaluation, type this command. Here the dataset name of your file, and the results will store in this file. Let's see a quick run of it. These are the two scripts in our project. This one is generate.py. This is used to generate the complete 3000 rows of prompts, and this one is eval.py, which is used to evaluate those generated prompts into different multiple LLMs. If you want to change the models which you want to test on, you can also change script accordingly. So let's start a quick run. To run the code, I already shown the command in the GitHub readme file. So let's start the execution. As it takes much time to test all the 3000 prompts, I have copied first 10 rows of the generated dataset to a small sample file and ran this evaluation script on this sample file. This is the output I got. The final scores are, don't mind the Gemini errors as I hit free tier quota limit. These are the vulnerable scores. In our run for the first 10 prompts, Grok is more vulnerable. Means Grok is unsafe more than the other 3 LLMs we test. So that is our project. Go check it out once. You can feel free to share your thoughts, questions and feedback. I'll also drop my LinkedIn profile in the description. You can feel free to contact me anytime. Thank you. Let's meet in the next video.